Dear students, let us see the next expression for time domain specification, that is a peak time TP. So let us find the expression for peak time TP. So what is peak time? As per the definition of peak time, we all know that at time t is equal to TP, C of TP is equal to maximum value. So peak time is the time at which C of t becomes maximum here. So we can see this is TP, peak time, at which C of t becomes maximum. So how to derive an expression for this peak time? For that, let us consider here the concept of derivative of a function. So that means the d by dt of C of t at time t equal to TP will be equal to 0. So the derivative at the peak will be equal to 0. So if you're taking the derivative of this C of t, then it's this is C of t. We all know that this function is C of t. So if you're taking the derivative of this function at a time t is equal to TP, then its derivative will be equal to 0. So its maximum value means the derivative becomes 0. So this is the concept which we are using for finding the expression for TP. That means that we are taking the derivative of C of t and putting t is equal to TP, and that we are considering that will be equal to 0. So once again, let us take the response of the system, second order system for underdamped case. So that is C of t here. So you have to learn this expression, you have to by heart this expression, and differentiating C of t with respect to t, that means we have to find d by dt of C of t. So first of all, d by dt of 1, then minus d by dt of the next term, d by dt of this term. So if when we are taking the d by dt of 1, that will be equal to 0. So when we are taking the derivative next term, that is in fact it's a product term, an exponential term and a sine term, that's a product term. So let us use the product formula here. So the first function e power minus eta omega nt divided by root of 1 minus eta square into derivative of the second term, that is sine omega dt plus theta, will be equal to what? So derivative of this term will be equal to cos omega dt plus theta, sine theta, derivative cos theta, then omega dt plus theta, we have to multiply by omega d. So d by dt of omega dt plus theta will be equal to what? Omega d by dt of t, that will be equal to 1, omega d by dt of theta will be equal to 0. So multiplied with the omega d minus, so here the negative sign is outside, so minus second function, that is sine omega dt plus theta, into derivative of the first function. So derivative of e power theta will be equal to what? The same function, e raised to theta, that is e raised to minus eta omega into t divided by root of 1 minus eta square into derivative of this term, that will be equal to minus zeta omega n. Okay, so e raised to ax, if you take in the derivative of e raised to ax, that will be e raised to ax into a. Okay, that means d by dx of e raised to x will be equal to e raised to ax into derivative of this term ax, that is equal to a. So in this way, e raised to minus zeta omega into t into minus zeta omega n. So first function into derivative of second function, here comes a plus minus sign here because the outside is a minus second function into derivative of the first function. So here that has been rearranged here. So there is a negative sign here that is multiplied with this term, that will become positive here. So this so we know that so we have just seen that the derivative of c of t will at time t is equal to tp will be equal to 0. So you have to put time t is equal to tp, then its value will be equal to, you have to consider that its value will be equal to 0. So this term here, minus e power minus eta omega n t divided by root of 1 minus eta square cos omega dt into omega d plus sine omega dt plus theta e power minus theta omega n t divided by root of 1 minus eta square into theta omega n will be equal to 0. There we have to replace t by tp. Every t is to be changed by tp, because at t is equal to tp, this will be equal to 0 at peak time. At peak time, derivative is equal to 0. So when the term becomes 0, what happens here? So we can see, we can take this term to the right hand side. So we are taking this first term to the right hand side. So the negative sign is here, so that is goes to the right hand side. So the left hand side, this term will be here, sine omega dt plus theta omega d tp plus theta e power minus zeta omega n tp divided by root of 1 minus zeta square zeta omega n. So this term is the left hand side and this term goes to the right hand side. So what happens here? Let us consider. So this sine omega dt plus theta and this cos omega dt plus theta goes to the left hand side. So this term goes to denominator here. This term, these two terms are equal, so we can cancel it out. So what remains in the right hand side here? Omega d is here, and there is a zeta omega n is here, that goes to the right hand side, that goes to the denominator. So what is in the denominator? Omega d divided by zeta omega. So omega d is what? Omega d is omega n into root of 1 minus zeta square. So this omega n get cancel out. What is in the right hand side? Root of 1 minus zeta square divided by zeta. So the left hand side, this is sine by cos, which is equal to tan omega dt plus theta, which is equal to tan theta, because this root of 1 minus zeta square by zeta, we know that that is equal to tan theta. Now once again, so we are getting it as tan omega dt plus tp is equal to tan theta. So we know that tan 180 plus theta is equal to tan theta. So here tan omega dtp plus theta is equal to tan theta. But as per the standard rule, tan 180 plus theta is equal to tan theta. So we have to consider that this omega dt plus omega dtp is equal to what? 180. That is equal to pi. Omega d Tp is equal to pi. So Tp is equal to what? Pi by omega d, or pi by omega d is omega n in root of 1 minus zeta square. So the peak time expression we are getting as pi by omega d, or pi by omega n into root of 1 minus zeta square. So that is the expression for peak time.